In this video, I'll be going over how to find the area between two curves. So suppose we have two functions, f of x and g of x, and f of x is always greater than g of x over some interval. Let's call the interval a to b because that's what we call most intervals. So here's our interval a to b, and we want to find the area in between these two curves. So formally, let f of x and g of x be continuous functions over the interval a to b, such that f of x is always greater than g of x. Then the area between the functions r, so we can call this area r, is given by the integral from a to b of f of x minus g of x dx. Okay? If you just think about this intuitively, suppose we just had the function f of x and we found the entire area over that function, or under that function, between f of x and the x-axis down here. Okay, so if we found the entire area between f of x and the x-axis, that would give us the first part of this integrand. And then if we subtracted the area between g of x and the x-axis, that would leave us with that area r. Okay, so this is what we'll be looking at in this video. So our first example says, if R is the region bounded by the graph of the functions f of x equals x plus 4 and g of x is equal to 3 minus x over 2 over the interval 1 to 4, find the area of R. So in all of these questions, what we're going to want to do is graph the functions and identify the region that we're talking about. Once we can identify the region, then we'll set up the integral and we'll integrate. Okay, so I've graphed f of x and g of x, and we want to look at the region between 1 and 4. So we're looking to identify, or we're looking to find the area of this region, and we're calling that region R. So because f of x is always greater than g of x, when we compare those two, so f of x is always greater than or equal to g of x, what we're going to do is to set up this integral, we're going to say the region R is equal to the integral from 1 to 4 of f of x minus g of x dx. Okay, so we'll just substitute everything in, integrate, and then evaluate whatever we get between 1 and 4. So simplifying the integrand, we have 3 over 2 times x plus 1. So integrating, we're going to have 3 over 2 x squared over 2 plus x. We're going to evaluate that from 1 to 4. I can combine the 3 halves times x squared over 2 into 3/4 x squared. Okay, so evaluating this, first at 4, we have 4 squared times 3/4, so 4 squared is 16 times 3 is 48 over 4 plus 4 minus 1 squared times 3/4 is 3/4 plus 1. So 48/4 plus 4, well that's 16/4, so 64/4 minus 3/4 plus 4/4 is 7/4. That leaves us with 57/4 as the area for region R. Our next example says to find the areas between the curves of the functions f of x equals 9 minus x over 2 squared and g of x equals 6 minus x. So again, let's go ahead and draw the functions. Okay, so here's what the graphs of these functions look like, and we're looking for the area in between. Now, what we'll need to do is determine the x-coordinate where these intersect, because that will be the limit for the integral. So in order to find where two graphs intersect, we can set them equal to each other. So we'll say 6 minus x is equal to 9 minus x over 2 squared. I'm going to write that as x squared over 4. So we solve this equation. It's quadratic. We'll set it equal to 0. X squared over 4. Subtract 9 from both sides. We end up with x squared over 4 minus x minus 3 is equal to 0. Multiply through by 4. Factor. And solve for x. So we get x is equal to 6 and negative 2. So the eye test confirmed that the graphs cross at x equals 6, and then they also cross at x equals negative 2. So once we have the limits for the integral, we just set up the integral. F of x is always bigger than g of x, so we'll do f of x first. So 9 minus x squared over 4 minus g of x, which is 6 minus x, and then we just integrate. So my recommendation would be to pause the video and see if you can evaluate this definite integral on your own. Alright, so we end up with 64 thirds. We just go through, find the antiderivative of the integrand, and then evaluate at negative 2 and 6, subtract, and we end up with 64 over 3.